Okay, so hello again. Now, here we are again with another SAP2000 tutorial, this time on cables. Now, let me show you what I got here. So, I have taken the time to design a bridge, and I quote bridge because the bridge engineer guys who will be watching this video probably won't like too much what I'm going to do. But this is what we're talking about. So once again, I am going to be using some of my favorite techniques to simulate this in SAP2000. So you can go back to the videos that I've previously posted on those just to get an idea. But if not, just keep watching this and perhaps shed a little bit more light. So, as I said before, I am going to be simulating these cables today on SAP2000, and as you probably already noticed, I've got quite a few layers here. Well, 3 actually. So let's have a look at the layers. So I've got the area, which is in red, and it's the deck of the bridge. Let me just go into realistic view. There you go. Okay. And I'm going to be using a grill to support the deck of the bridge. Now, this is a pedestrian bridge and it's a conceptual design. Now, that's, as you can see, that's 10 meters, and that's probably the reason why the bridge guys are going to hate me. But never mind. Alright, so there's a reason why cables are on a different layer. And that reason is because I am not going to be adding that into SAP2000 layers for the simulation. On the contrary, I'm going to be designing the cables on SAP and drawing them on the spot. So let's take this, save it as a DXF, and go into SAP2000 and run the simulation. So bridge test, let's give that a 2010, save. Oh yeah, replace that. Okay, so let's move into SAP2000 and have a look at the simulation of these cables. Okay, so here we are in the amazing SAP2000. Now, the first thing I'm going to do before I import my DXF is change my units from here to kilonewton meters. Now, let's import DXF of our bridge, and for that I've got that on the VBox server. Bridge test. Okay, so Z is up and we're working in kilonewton meters. Frames, go to frames. Once again, I'm not going to do anything with the cables, I'm just going to totally ignore the layer. Shells to areas, and let's have a look. So there we go. Now, the next thing I'm going to do before I do anything else is define my sections. So, for the deck, I'm going to be using a 100mm concrete decking. Let's not change those properties. 0.1 and OK. So, now I'm going to assign that, assign area. Sections, deck. Okay, so there you go. Just assign deck there. Now the next thing I'm going to do is assign my grillage, and for that I'm going to try and use the lowest and the smallest basically I-beam in the bridge standard parts. So frame sections, import a new property, go to BS shapes. And let's go to universal beams. No, let's go to a 254. 43 is a bit overkill for this. 25 might work. Let's go 30 just to make sure. And now everything is assigned the I-beam. Now, the reason why I selected everything and did it that way, which is not a very good way to start with, is because it's easier for me to change the sections on the actual columns of the bridge rather than just selecting each one of these two in there. But you can do it any way you want. So now I'm going to change the frame for the columns, and for that I think I'm going to be using a circular hollow section. So let's have a look in the British Standard shapes, and I think that as 10 meters, maybe a 273 would be a little bit too small. Let's go to, yep, let's try that. 273 by 12.5, nice thick section, half an inch. Okay, so let's have a look at how this looks before we start. Oh, that's not bad. It's quite beautiful actually. Alright, so let's add the restraints and let's jump into the design of the cables. So I'll make that fully fixed, which is not the case, but I'm not a bridge engineer. So now, before I start drawing cables, I need to actually go into SAP2000 here, the define menu, and define the cables. So I want to use a 25mm, 25/4, that's 1 inch. Now let's change the display color just to make this model a little bit prettier. There we go. Cable done. Now I'm going to click on the draw frame cable element, and I'm going to choose from the line object type cable. Now the section is automatically defined, but as soon as you click where on the 2 points that the cable is going to be assigned, you're going to get a big menu in front of you, this one. So I'm not going to go into too much detail as to what all these mean in here, but what you need to know, the two most basic and most important parameters in here is the type of the cable that you're going to be using, which in this case is an undeformed length cable, and I'm going to be modeling the cable as a straight frame object. So unfortunately I'm going to have to do that for all of these, so let's have a look at that. I'm going to fast forward this video a little bit. Okay, so I have just drawn the cables, so let's have a look if everything looks right. 1, 2, 3, 4 and 1, 2, 3, 4 cables, so that looks pretty good. Now the next thing I want to do is assign the loads. So for that I'm going to go to assign area loads, and I'm going to use uniform shell. I'm going to add a live load, and of course, as always, I'll be naming that LV1. Okay, choose it, and let's go a bit overkill here. Let's go 3.5 kilonewtons. Maybe that's too much, but never mind. Okay, so there we go. Now we got the loads assigned to our bridge. Let's have a look. 3.5 gravity direction, and now I'm going to run the simulation. I'll replace that. Okay, so there you go, that's a bit of deflection right there. Now again, I'm not a bridge engineer, so I don't really care about what we're looking at here rather than the actual design process in SAP2000, and we have 50mm of deflection in the center, which is not that bad, and we probably should have about 50mm on the top here. Ooh, beautiful. So now let's have a look at the actual design. I'm very curious as to if this is going to work or not. Let's try Eurocode. Oh, it looks like these guys here are failing. Okay, so let's ask SAP2000 if everything is alright. Verify the sections. Oop, 2 steel frames are the sections that always fail on bridges, these little puppies here. But never mind, that's something for the bridge engineers to scratch their heads. Okay, so this is the end of this tutorial. Now you know how to simulate basic cable designs on SAP 2000. Now, the next thing that you would probably need to do for a bridge is start looking into vortex shedding and resonance frequency. That's a lesson that we learned from the Tacoma Narrows. So at this point, I'm going to bid you goodbye, and we are going to see each other very, very soon. Now, if you want more information on the calculations of vortex shedding and wind engineering in general, please do drop me a text on the comment section below or private message me on YouTube, and I would be more than happy to provide. Good night.